Hello, this is the fifth video of the first sequence and series section on summing series for OCR Pure Core Further Mathematics. It looks at the method of differences. The method of differences involves expressing the terms of a sum in such a way that parts of a sum can be cancelled in a regular pattern. Expressing the terms of difference will often require the use of an algebraic identity, and these sums often involve algebraic fractions, algebraic products, or factorial expressions. In typical questions, the first stage is to establish how the sum can be expressed in the form of a difference of two or more terms. For example, here we need to show that 1 over r minus 1 over r plus 1 is equivalent to the 1 over r plus 1. You can do this by simple fraction manipulation. You might then be asked to use this to find an expression for the summation. So writing that then as the sum of 1 over r between r equals 1 and n, subtracting 1 over r plus 1. Writing these out vertically, we would see that this would give us 1 minus a half, and then a half minus a third minus a quarter, going on down to finally 1 over n minus 1 over n plus 1. I've written these vertically because that's how I like to set it out. You can see here then that there is that pattern, minus, plus a half, plus a third, minus a third, and so on, and that the cancellations would proceed down the vertical columns, including with the minus 1 over n, until what you are left with is the 1 and the minus 1 over n plus 1. Which can be rearranged as n over n plus 1. Here we have the same expansions shown horizontally, with colours showing where we have cancelled out. Here we have an example with an algebraic product. Simplifying this expression, we simply take out the common factors of r plus 2 and r plus 1. Leaving us with r plus 3 minus r, which would cancel. We can then use this, noting that there is this factor of a third, because we have 3 times what we want here compared to here, of the r plus 3, r plus 2, r plus 1, minus, again we would have that factor of a third, r equals 1 to n. So you can see where the two differences come from. Writing these out again vertically, the terms we would get, and I'm going to ignore this factor of a third for the moment, but I will remember it at the end. And so on. So those terms. So these are the terms from this expression up here. And then these are obviously the ones we're subtracting from the method of differences. The last term would be n plus 3, n plus 2, n plus 1. And then we'd have our n plus 2, n plus 1, n. You can see that that term and that term would cancel, and therefore that, and that pattern of cancellations would go down through the two columns up to and including that one, thus leaving this term here and this term here as the only, if you like, survivors, remembering that we're going to multiply this by a third. Here we have the same expansions done horizontally and slightly more neatly, resulting in the third of minus 6 plus the n plus 3, n plus 2, n plus 1, and then going on to manipulate this further algebraically. You may like to follow this more carefully for yourselves when you pause the slide, but the result is n over 3, n squared plus 6n plus 11. Moving on then to look at factorials. We remember that 5 factorial is 5 times 4 times 3 times 2 times 1, and that n factorial will therefore be n times n minus 1 times n minus 2, and so on down to 2 times 1. So relationship, for example, between 6 factorial and 5 factorial is 6 times 5 factorial, and n plus 1 factorial would be n plus 1 times n factorial. In showing that r plus 1 factorial minus r factorial can be written as r times r factorial, you would therefore write it as r plus 1 times r factorial minus r factorial, taking out plus 1 and then minus 1. This then can be used to find the summation of r times r factorial, which is an exercise in integral level 1, and therefore I will leave it to you to try for yourselves. This is the last video in the first sequences and series section.